So I thought I would do some voiceovers for the feedback PowerPoints as we move forward. I know it's not the same as having a proper lesson, but hopefully looking at the PowerPoint and hearing me talk through what the PowerPoint is showing you will be a little bit more helpful than just reading the PowerPoint yourself. So for activity 1, you had to look at the 3 different types of rainfall, so orographic relief rainfall, convectional rainfall and frontal rainfall. You had to use the web link and the diagrams and pictures or maps to help you work out, first of all, how the rainfall is formed, so the explanation of that rainfall formation, and then the location where that rainfall might take place. For orographic rainfall or relief rainfall, called relief rainfall because it happens when it comes into contact with areas of high relief, the explanation is that warm moist air, which has had to travel over an ocean or a sea to pick up that moisture, is forced to rise into the atmosphere, in this case over an area of high relief such as hills and mountains. As the air rises, it cools and subsequently reaches that dew point which you learnt about on the pages before this activity, resulting in condensation and water vapour changing into a liquid. So on the side of the mountain where that rain is forced upwards, you will find heavy rainfall as that air is condensing down and that water vapour is changing into a liquid. As you can see on the other side of the mountain though, as that air moves over that area of high relief and it starts to sink, what's going to happen is that air is going to warm up, it's going to dry out, and the other side of those mountainous regions will experience a rain shadow. So one side, the side where the prevailing wind is coming into contact with the mountain, you'll get higher levels of precipitation. But on the other side, you'll actually get less precipitation than the average, because it's in that rain shadow. So the air has descended, it's already lost lots of its moisture as it came into contact with the mountainous region in the first place, and as it's descending, it's warming up and it's becoming drier. In terms of the locations, so where do we find this type of rainfall? In the UK, our prevailing winds are coming from a westerly direction, so we get lots of rainfall in the upland western regions of the UK, as those westerly winds from the Atlantic Ocean rise over areas such as Dartmoor, Snowdonia, the Lake District and the Highlands of Scotland. So if you look at the map at the bottom of that PowerPoint slide, you'll see that on the western areas, or in the western areas of the United Kingdom, you've got very, very high levels of precipitation, often exceeding 2,000 millimetres per year. So you've got lots and lots of rainfall. In terms of how do we know which direction those prevailing winds come from, we're going to talk about that in more detail when we move on to look at weather and climate in year 13. So if you were looking at other areas of the world and wondering which sides or which directions around mountainous regions experienced high levels of rainfall, you'll learn about those wind directions in much, much more detail when you move into year 13. So for convectional rainfall and also for frontal rainfall, as you can see from the diagrams, just like the orographic rainfall, the process of rainfall formation occurs when air moves upwards in the atmosphere, condenses and forms those water droplets. So for all 3 types of rainfall, the end part of the process is that air is rising into the atmosphere and forming the rainfall. It's just the method that causes that air to rise, which is different for each of those different types of rainfall. For convectional rainfall, it occurs due to the process of convection, as the name suggests. So it occurs when the energy of the sun or incoming solar radiation, so insolation, heats the Earth's surface and causes water to evaporate, changing to water vapour. So as the Earth's surface is warmed, any water on the surface is going to evaporate. That's going to start to then rise upwards, cool down when it reaches higher points in the atmosphere, reaching that dew point, as I said on the slide before, and it's going to result in that condensation and that water vapour changing into a liquid. The process of condensation, in this case, because it happens relatively quickly and with relatively large amounts of water, leads to the development of large towering cumulonimbus clouds, which are storm clouds. As these clouds continue to grow, so if you've got a really long hot summer's day, it's going to continue evaporating water up into the atmosphere, so the clouds are going to continue to grow. The weight of the water droplets can eventually lead to precipitation, so you tend to get big thunderstorms and rainstorms after particularly prolonged periods of hot weather, hot and dry weather. In the UK, this happens as well. It happens particularly in the southeast of the UK because this is the part of the United Kingdom which is closest to the continent of Europe. And Europe, the large landmass of Europe, will warm up particularly quickly due to a process called continentality. So the large landmass will warm up much more quickly due to its specific heat capacity than the smaller landmasses such as the UK, which are surrounded by water, which takes longer to warm up and therefore doesn't have as big an impact. Okay, but again, we're going to learn about that process of continentality in year 13 when we do weather and climate. So the final method of rainfall formation is something called frontal rainfall, and as you can see at the bottom of this slide, again, this is something you're going to learn about in much more detail in the weather and climate topic. Just like the other two types of rainfall, air is moving upwards in the atmosphere, cooling down, condensing, and producing those water droplets which will turn to rain. This type of rainfall, frontal rainfall, involves the collision of two different air masses. So air masses are bodies of air which have different temperature characteristics and different moisture characteristics, so different density characteristics. And again, you're going to learn about this in much more detail in year 13 when you do your weather and climate topic. When you get a collision between two air masses which have got contrasting temperatures and therefore contrasting densities, they don't just mix. Okay, so you've got a body of hot air colliding with a body of colder air, and the air particles can't just mix easily together. The front is the boundary which separates those two contrasting air masses. So the front separates that cool air coming, as you can see from the satellite image at the bottom of the pack, so coming from the north. The front will separate the cold body of air from the north from the warm body of air which is moving northwards from a southerly direction. Colder air is denser than warmer air. We all know that because we all know that warm air rises. So at a front, warm air will be forced upwards into the atmosphere. So the warm air will ride up and over that body of cold air. As the air rises, as I said for the other two slides, it's going to cool down, it's going to subsequently reach that dew point. That's going to result in condensation and water vapour changing into a liquid, and that is going to lead to frontal rain. So you will get rainfall along that collision zone, that frontal boundary, as those two air masses meet, and as that warm air from the south is forced up and over that colder air which is moving down from the north. Just like the other two fronts, this type of rain commonly affects the UK. So due to its latitude, again you're going to learn about this in much more detail in Weather and Climate in Year 13, we're often located where warm tropical air is colliding with cold polar air. So we're actually at a point where global atmospheric circulation almost continually causes these fronts to form over the United Kingdom. So, as you've seen on the last three slides, the United Kingdom is quite a wet location because we're affected not just by frontal rainfall, not just by convectional rainfall, not just by orographic rainfall, but all areas of the UK are affected by at least one of these processes, if not two, if not three, or if not obviously all of those processes. So question activity 4 was asking you to look at a range of data sources, so a data table, a map, a choropleth map which uses colour, and then a graph, a hydrograph, and the activity was broken down into 3 parts, and it was asking you to look at those data sources and describe what they're showing you. So it's in the style of the short 5-mark data response questions which you could get asked in the real exam. Obviously, they're not real exam questions, but the skills that you use to answer these questions are going to be the same skills that you use when you answer proper exam questions. So you're still developing your exam skills, just using the recent rainfall data. Part A for this question is asking you to look at a table of data. So it's asking you to look at the winter rainfall, and in particular the February rainfall for the United Kingdom in comparison to the average rainfall for that time period. You've got 2 main columns, so you've got the winter 2019-2020 rainfall, and then you've got the February 2020 rainfall. Each of those main columns is split into 2 sub-columns, so it's got the actual rainfall measurements measured in millimetres, and it's got the percentage anomaly, which means how much more rain fell in those time periods compared to the average for the 1981 to 2010 30-year period. So if the number's over 100, it means you had more rainfall than you'd normally expect at that time. As you can see, if you look at the winter rainfall figures, you can see that for the UK, for England and for Wales, so those separate parts of the UK, you've got more rainfall than average. Now for this question, even though it's got the February 2020 rainfall column present in the data table, you don't actually have to refer to it in your answer. If it was a real exam question, you wouldn't lose marks if you didn't refer to it, because if you look back to the question itself, it's asking you to compare the winter rainfall. So if you talk about February, that's fine, because it's obviously a month within the winter, but you can just focus your answer just purely on that winter column. As you can see, the UK average precipitation level was 469.7 millimetres, and that represents 43% more rainfall than the average for that period. So you can see that the rainfall for the winter was 43 times more than the average that we usually get. As you can see, it was quite similar in England and Wales. So England again got 43% more rainfall compared to average. Wales a little bit less, but they got 41% more rainfall than they would normally expect. Part B really builds on that question. So part A is looking at the raw data, and it's looking at the overall figures for all of the UK, for England and for Wales. But for part B, you're then referring to that choropleth map, which is using colour to represent levels of rainfall. And you can see in that choropleth map that the entirety of the UK experienced higher levels of rainfall compared to that 1981 and 2010 average. And the way that you can tell that is that if you look at the key on the side of that map, all of the UK is pale purple, maybe blue, maybe moving up to that bright pink at the top of that key. There aren't any areas which are actually white, apart from a very small section of Northern Ireland. If you're looking at a question which involves a map and you've only got 5 minutes to answer the question, it's not really realistic for you to take the map and talk about it region by region, especially if it's a map of Europe or a map of the world. You're not going to have time in 5 minutes to actually break it down into those regions. The best way to tackle any kind of map question is to use the key to help you. So as you can see in the example answer on this slide here, the key has been split up into areas of highest rainfall, so over 300% of the average. It then looks at the lowest section of that key, so the lowest levels of rainfall. We've chosen 150% of the average and below, and then it looks at that middle section towards the end of that answer. In terms of splitting the key up, you don't always have to split it up equally. So you can see we've focused on just the very highest and the very lowest in our answer. In some cases, if you did just have 3 sections, it would make sense to split it up equally into those 3 sections. But for this question, talking about the patterns of rainfall, it does make sense to talk about the very, very highest, the very, very lowest, and then the middle bits obviously will just fall in that in-between category. As you can see from the model answer, or the example answer, it's not a model answer because I'm sure you could all write perfect answers as well. For each section, we've stated what the section is. So highest levels of rain are over 300%. We've then given examples using geographical locations. So for the highest percentage, areas of Snowdonian, North Wales, moving eastwards through the North Midlands of England. And we've also got a second band in Northern England following the Pennines from Manchester into the south of the Lake District in the north. Now, as you can see in that example answer, it's actually naming geographical regions which are named on that map. So one of the things we expect you to do as you move into year 13 in particular is just to keep developing your general geographical knowledge. So learning the counties, learning the mountain regions, learning the national parks for the UK, naming parts of Europe and countries within Europe, naming key countries across the globe. We'd really be expecting you to have that background knowledge to really help develop your answers. So part D of activity 4 is your final part where you had to write an answer because part C was watching a video link. It's looking at a hydrograph for the River Teme at Tenbury, and it's asking you to use correct terms which you learnt in Unit 1, so applying your knowledge from a separate unit, to describe that hydrograph for the River Teme at Tenbury during that period of prolonged rainfall. For a graph question, you've got to use the information given to you to help your answer, to help develop your answer. So the graph on the x-axis has got the date, so from Thursday the 13th of February to Monday the 17th of February. On the y-axis, you've got the measured level of that river. Okay, so you've got your y-axis showing you the measured level of the river during that rainfall event. Now, it's not labelled on here, but the orange line on the graph is showing you the period the level of the river which is classed as bank full discharge. So you can also mention that. If you look at the answer here, you can see that the way this answer has been constructed, just like the map on the previous slide, the graph has been split up into sections. It's been split up pretty much into day by day sections because each day seems to have something different happening on it in this case. But you don't have to split it up into day by day sections. You can split it up just into changing sections on that graph. So if you had a graph with 50 days on, for example, you wouldn't need to split it up day by day. You just split it into sections where you've got clear changes shown on that graph. As you can see in the example answer, you've got lots of reference to those terms which relate to hydrographs. So you've got reference to rising gleam, you've got reference to falling gleam, you've got reference to peak, bank full discharge. And because it's a descriptive question, you've also got loads of describing words in there as well. So it doesn't just say the graph increases or decreases, it's actually differentiating between the type and rate of change. So you've got rapid or steep rising gleam to start off with. You've got a more gradual falling gleam. You've got again a dramatic and steep rising gleam, a period where it fluctuates but remains constant for a short time on the 16th of February, and then again you've got a rapid drop to the end of the hydrograph. So you've got reference to dates, you've got reference to river levels, and you've got reference to types and amounts of change as well.